Hello and welcome back to the final part of the review for the college algebra final this semester. Let's just go ahead and get right into it. Where the first question we have here is solve the inequality. So what I'm going to do is, first thing I'm going to do is I'll distribute this 2 to both of these. So this is 2x plus 4. And I'll subtract both of these over. So we have 3x squared minus x minus 4. So we need to figure out where that is true. Well, because like this number in front is positive, like I know this opens up. So just to make a rough sketch of what this looks like. Be something like this, right? And we're looking for ones below 0, so we care about this section. Because all that's below are 0. So we need to figure out what, where are our zeros here? It want to be the ones in the middle. So, in order to do that, we use our quadratic formula. So, it's a quadratic formula, you don't remember, it's negative b plus or minus square root of b squared minus 4ac all over 2a. So, 1 plus or minus square root of negative 1 squared is 1, minus 4 times 3 times minus 4 all over 2 times 3, and that's going to give us 1 plus or minus square root of 1 minus, and then, 1 minus, 4 times 3 times minus 4 is going to be minus 48, so it's really going to be 1 plus 48, all over 6. 1 plus 48 is square root of 49, which is 7. So we're going to get 1 plus 7 over 6, which is 8 over 6, which is 4/3, or 1 minus 7, which is negative 6 over 6, which is just negative 1. So that means right here was negative 1, right here was 4/3, and we want the part that's below 0, and I can tell this opens up from that. So I'm going to go in the middle. So it's going to be negative 1 comma 4 over 3. And that is our solution for that one. Going on to the next one. It is x plus 2 times x plus 5 times x minus 4 is greater than or equal to 0. Well, in order to figure out this one, what I'm going to do is, it gives us to us factored. So I'm going to say, okay, our zeros are at negative 2, minus 5, and 4. And I'll make a number line. Minus 5, minus 2, and positive 4. And I'm going to check the number to the left of minus 5, in between minus 5 and minus 2 and 4, and above 4. And I'm going to plug it into this. If it's greater than 0, I'm going to include that section. Like, if that is true. So let's try negative 6. If I plug negative 6 into here, I'll get negative 6 plus 2, negative 6 plus 5, minus 6 minus 4. Well, minus 6 plus 2 is negative 4 times negative 1 times minus 10. Well, minus 4 times minus 1 is positive 4. Which gives us negative 40, and that is not greater than or equal to 0, so I'm not going to include that section. Well, what about for a number between minus 5 and minus 2? Well, let's try, I don't know, minus 3. You can pick really any number in between. So, minus 3 plus 2, minus 3 plus 5, minus 3 minus 4. Well, minus 3 plus 2 is negative 1, times minus 3 plus 5 is positive 2, and minus 3 minus 4 is negative 7. These two negatives cancel, so I have 1 times 2 times 7, which is 14, and that is greater than or equal to 0, so that's going to work. I'm going to include from minus 5 to minus 2. Okay, I'll pick another number. I'll pick 0, because that seems pretty easy. Well, when I plug in 0, I just get 2 times 5 times minus 4, which is 10 times minus 4, which is again minus 40, and that is That's not true. So I'm not going to include that. And pick a number bigger than 4. I'll pick 5. So I'll do 5 plus 2 times 5 plus 5 times 5 minus 4, which is 7 times 10 times 1. And that's gonna be 70. And that's greater than 0. So after doing all that, what is my answer here? Well, my answer is going to be from minus 5 to minus 2. And I'm going to do brackets because I can't, it was or equal to 0, and that's where it is 0, so I'm going to include them. And then I'll do union, bracket, from 4, comma, infinity, parentheses. Because those are the intervals for which it worked. Going to this next one, I'm going to kind of use a similar process of what I did in part B of the last one. Solve the rational inequalities. Well, I'm going to figure out when the top equals 0 and when the bottom equals 0. So that's x equals 3 and x equals minus 2. Put a little number line. I'll have minus 2, positive 3. I'm going to take one spot to the left, in the middle, and to the right to see if that's true. So if I try, I don't know, minus 3. Okay, let's try minus 3. So minus 3 plus 2 over minus 3 minus 3. Well, that's going to be negative 1 over negative 6, which is 1/6. And it needs to be below 0, and that's not true. So that section's not going to work. Okay, what about right here in the middle at 0? Well, 0 plus 2 is 2. 0 minus 3 is minus 3. Negative 2/3 is, that works. The middle is going to work. Let's pick a number bigger than 3. So let's try 4. Well, 4 plus 2 is 6, and 4 minus 1 or 4 minus 3 is going to be 1. So 6 over 1, which is positive 6. Well, that's not less than or equal to 0, so that's not going to work. So for this first one, our answer is going to be from minus 2 to 3. And it can include 0, right? So I'm going to include minus 2. Because if I plug minus 2 in, I get 0, because minus 2 plus 2 is 0 over negative 5. But I'm not going to include the 3, because if I try to plug that in, I'll get something divided by 0. Because 3 minus 3 is 0, and then you get some, you just can't divide by 0. Going to this next one, with 2 over x minus 1, it's greater than minus 4 over x. What I'm going to do is I'm going to add this over, so 2 over x minus 1 plus 4 over x greater than 0. And then I'm going to combine these with the same fraction. So multiply the one on the left by x over x. This one times x minus 1 over x minus 1. So I'll have 2x over x times x minus 1 plus 4x minus 4, just distributing that, for x times x minus 1. So what am I going to get? I'll get 6x minus 4 over x times x minus 1, greater than, or just strictly greater than 0. And so I'm going to set the top equal to 0, which you get x is going to be 2/3 if you set it equal to 0 and solve. Set the bottom equal to 0, you get x equals 0 and x equals 1. And so those are going to be like the spots on the number line. I'm going to check. I'll put my number line down here. We have 0, we have 2/3, we have 1. And we're going to go through and we're going to check each of these. So if I try something less than 0, so if I try like negative 1, well, 6 times minus 1 minus 4 over negative 1 times minus 1 minus 1. That's going to be negative 6 minus 4 over negative 1 times negative 2, which is going to be negative 10 over 2. And that is not greater than 0, so that's not going to work. Something between 0 and 2/3, well, 1/2 is in between. 2/3 is like 0.67. I don't know if that's going to help, you visualize what that is. But so if I try 1/2, so I'll do 6 times 1/2 minus 4 over 1/2 times 1/2 minus 1. Well, 6 times 1/2 is 3 minus 4 over 1/2. 1/2 minus 1 is negative 1/2. So we get minus 1 over negative 1/4, which the negatives cancel. In 1 over 1/4, treat as 1 over 1, keep, change, flip. So 1 over 1 times flip that to 4 over 1. It's just 4, which is greater than 0. So that works. So between 0 and 2/3, that's a yes. Okay, what about between 2/3 and 1? And let me think. What is the number between 2/3 and 1? That's going to be okay to plug in. I want to do 5 over 6. And I just did that because, like, I don't know, I just picked that one pretty randomly. You can check your calculators between 0.67 and 1. So 6 times 5 over 6 minus 4 over 5 over 6 times 5 over 6 minus 1. Well, that will give me 5 minus 4 over 5 over 6 times, it would be negative 1 over 6. So it gives me 1 over negative 5 over 36. Keep, this is 1 over 1 times 36 over minus 5. So negative 36 over 5 is what we get. And that is not greater than 0. That's not true. So that does not work. Okay, and let's just go ahead and try a number just bigger than 1. So finally, something other than fractions again. I don't know, 2. So 6 times 2 minus 4 over 2 times 2 minus 1. I don't know why I put parentheses there. There doesn't need to be 1. 6 times 2 is 12 minus 4. 2 minus 1 is 1. So we get 8 over 2, which is 4. And that works, because that is greater than 0. So that means our interval is going to be from 0 to 2/3, union, and these are all parentheses because we're not including the possibility of it equaling 0, 1 to infinity. And that's our final answer for that. For this next one, it says given g of x and f and h of x, use composition functions to determine if g and h are inverses. Well, that just means they're inverses if g of h of x equals just x and h of g of x. Either way works. So I'll do this one first. So 7, I'll plug in my h for my x minus 3. Well, the 7's cancel. So I get x plus 3 minus 3. 3 minus 3 cancels, so we just get x. That one worked. And so the answer is yes. But just, so you can also see the other way around, because it can go either way. If I would have plugged g in for h, we get 7x minus 3 plus 3 over 7. The minus 3 and the plus 3 cancels. We get 7x over 7, which is just x. So yes, they are inverses. Going to the next one, it gives us a one-to-one function, and it says find the inverses. So in order to find our inverses, I'm going to replace my f of x with a y. And then I'm going to switch my x's and y's. So all my x's become y's, all my y's become x's. And now I'm going to solve for y again. So I will multiply each side by 3. So 3x equals 2y minus 5. Add 5 over. So 3x plus 5 equals 2y. And then divide by 2. So 3x plus 5 over 2 is y. And when it says inverse function notation, just instead of y, we're going to put a f negative 1 of x. And then we're done. So I'll go ahead and I'll rewrite that closer to it so we can go to the next one. Going to the next one, let's say y equals the 5th root of 2x plus 3. Switch my x and y's. 5th root of 2x plus 3. And now we that's a y. I'll put my y in there. And we need to solve for y. Well, to undo a 5th root, you raise each side to the 5th power. And now we can subtract 3, so x to the 5th minus 3 is 2y, and we can divide by 2. So x to the 5 minus 3 over 2 is our y. Inverse function notation, f negative 1 of x is x to the 5 minus 3 over 2. And that's it for that one. So this one is going to tell us that Sally wants to invest $35,000 for retirement. She can invest that 4.8% simple interest for 20 years or 3.6% interest compounded continuously for 20 years. Which option results in more interest? So let's find the interest from the first option. Well, interest for simple interest is just P times R times T. So that's going to be 35,000 times R, which is 0.048, times T, is 20 years. And we get 33,600. And now we can go ahead and do the second one. Well, this is compound continuously. So the amount after T years is going to be PE to the RT. But to find the interest, we will have to subtract our initial amount. So the interest is the difference between what we started with and what we end with. So that's how we're going to calculate that. So we'll figure out the amount we're going to have in 20 years, and we'll subtract what we have currently. So the amount in 20 years is going to be 3,500 e to the 0.036 times 20. And I'm going to go ahead and subtract that 3,500 to find the difference between what we end up with and what we started with, and that's going to give me $36,905. There's like in like 16 cents or something like that, but like it's pretty clear. Oh no, I did not want to erase that. We want to go with option 2. So I'll say for my answer, compounded continuously. And then I'll say the amounts. 36,905 versus 33,600. And I should put this in like more of a lengthier like word answer because it asked me as a word problem. But we're just gonna kind of like keep moving because these videos have been getting pretty long already. So next one is saying suppose that $12,500 is invested at 5.5% for 8 years. Determine the amount that would be in the account under the following compounding conditions: annually, monthly, quarterly. Well, compound interest is our amount of money we have in our account is going to be our initial 1 plus R, which is our rate, over N. N is the number of times we compound a year, to the NT, where T is the number of years. So compounding annually, that means once. So that's going to be 2,500. 1 plus 0.055 is our rate, over 1. We're doing 8 years, so it's just going to be 1 times 8. So 2,500. 1.055 is what we get on the inside, to the 8th. And plugging that in, you get 19,183.58. So that's our answer for the first one, 19,183.58 dollars. Now erasing this part, compounding monthly. Well, there's 12 months in a year, so 12,500, 1 plus 0.055 over 12 to the 12 times 8. And just plugging that straight into my calculator, I'll go ahead and get 19,389.34. And quarterly, well, the only difference is we're now going to be compounding it quarterly. That means once every 3 months. So quarter means 4, so 4 times a year. And when I plug it in for that time, I get 19,350.75. And that's it for that one. We'll put my $sign on there. Moving on. this next one. It's a two-parter, so I'll do the first part on this page, and then I'll go into the next one. So, a farmer depreciates a $120,000 tractor. He estimates the resale value in thousands of dollars of tractor. 2 years after purchase, 80% of the value from the previous year. Given him this equation. So find the resale value 5 years after the purchase. Round to the nearest thousand. So note that this is in thousands of dollars, just what this is saying. So just keep that in mind. So via 5 is going to be 120 times 0.8 to the 5, which I got was around 39.3216. So we'll round that to 39 because this is thousands of dollars, so 39,000. So our answer is going to be $39,000 because this is thousands. Now go on to part B. So now it tells us that in order to cost a tractor, it's $18 an hour in labor, $36 in fuel, and $22 in overhead costs. Now we figure out the cost to run that tractor for the first year. If we use it for 800 hours, include the hourly cost and depreciation. So I'll say our cost is going to be our hourly plus our depreciation. So for our hourly, I'm going to just add up 18 plus 36 plus 22, which is going to be $76 per hour. Note that our depreciation is in thousands of dollars, so I'm gonna say this is 76 divided by that's gonna be thousands of dollars per hour. It is, and to figure out the cost, well, that's how much it is per hour. Well, how many hours? 800. So our total cost is gonna be 76 over 1,000 plus 800, and this will give us the cost in thousands. And for depreciation, well, we originally started with a value of $120,000, so 120 in thousands. And after 1 year, well, our value is going to be just, we have the equation. It's 120 times 0.8 to the t. So after a year, the new value will be this much. So the value we lost is the difference between what we started with and what we ended with. And I just realized I put a plus. That's supposed to be a times right there. That's my bad. Sorry if there's any confusion there. When I plug that into my calculator, I get 84.8. And remember, this is thousands of dollars, so the total cost was $84,800. For the next one, wants to convert from logarithm equation to exponential form. Well, in order to do that, I'm going to I always like to make a little snail here. And I think about, as I go from left to right, what do I see first? Well, first I see a 9. And the next thing is going to be the exponent. Well, what's the second thing I see here? Well, when I go around, it's the 2. And what is that going to give me? Well, the last thing I see is the 81. And I'm going to do the same thing for this one. The first thing I see is my base, which is A. As I go around, the next thing I see is my exponent, which is C. The last thing I'm going to see is the inside, which is my M. Okay. I'm going to do pretty much the same process on this one. So I'll make a little snail. It's a weirder snail now. But when I write this out, log, well, the first number I got to write is my base. Well, the first number I saw here is 2. The next number I have to write is the inside. Well, the next number I saw in here, as I go around, is 32. And then my last number is going to be the one up here, which is 5. Doing the same thing with the next one. First number I see here is a C. I say number, even though it's a letter, that's okay.
Can you help me?
The next thing I see is this D, so that's going to be the second thing I put in my log. And finally, the last thing I see here is the N. So it's going to be the last thing I write in this. And now we're finished with that one. Okay, going on to this next one. It wants us to simplify the following using the basic properties of logarithms. So for this first one, we have ln of e to the y plus 4. Well, the log property it wants us to use is that if your base, in this case, this is the same thing as saying log base e. That's what natural log is. If your base matches, like if these match, then you just get your whatever your power is. So in this case, the natural log and the e cancel and your power comes down. On this next one, well, what if you don't have a power? Well, I mean, you could say you have a little invisible 1 there, but if it's just log base 2 of 2 and there's nothing else going on, it always just goes to 1. If the two things match, it always goes to 1. On this next one, well, if I have 4 to the log base 4, well, when your base, I guess when the base of the exponent matches with the base of the log, I don't know if, it's kind of confusing to phrase it. When these two things match, they cancel, and we just get left with this thing. So this is x squared. And finally, the log, no matter what the base is, if the inside is 1, is always 0. It could be natural log of 1, log base 10 of 1, log base 8, 10, or 13, 107. It doesn't matter. If 1 is on the inside, it's always 0. So this next one is going to say the formula pH equals negative log of the H plus represents the pH of a liquid as a function of the concentration of hydrogen ions. Depending on the pH of the following rounds to the nearest 10. So it gives us our H concentration, so we'll do negative log of 2 times 10 to the minus 13. And when I go ahead and plug that into my calculator, negative log of 2 times 10 to the minus 13. What I should get is, I got 12.69897, which is rounded to the nearest 10th, is going to be 12.7. For the next one, if I do negative log of 4.1 times 10 to the negative 10, I'll get 4.1 times 10 to the negative 10. I'll get 9.387, so I'll say 9.4 to the nearest 10th. So you just, in this case, just plug both of those in to the negative log. Make sure you be careful how you plug in the calculator, but you should just get the right answer from that. For number 70, we need to write the logarithmic expression that as sums and differences. So we got to break this up as much as we can. Well, the first thing I'm going to use is q over x to 3m. And when you have a log and there's division on the inside, you can break that into subtraction on the outside. So natural log of the 4th root of pq minus natural log of x third m. Okay, on this first log, I'll go and bring my screen down just a little bit. I can rewrite this as, on the wrong thing, as pq to the 1/4 power. And over here, I'll just rewrite this the same. And now I can bring my power out front. So I have 1/4 natural log of pq minus ln of x cubed m. Now I have multiplication on the inside. It's kind of similar, when you have division, it goes to subtraction. Multiplication will go to addition. Now note this 1/4 and the minus needs to stay out front of the whole thing. So natural log of 1/4 natural log of p plus natural log of q, and the 1/4 is on both of them, minus ln of x to the 3rd plus ln of m, and the minus on both of those. So I'll go and I'll distribute. So I have 1/4 ln of p plus 1/4 ln of q minus ln of x to the 3rd minus ln of m. And then I can bring this 3 down up front, so that gives me my final answer, which I'll put right here. 1/4 natural log of p plus 1/4 natural log of q minus 3 natural log of x minus natural log of m. And that is our final answer. Continuing on, this wants us to go the opposite way, so we're going to try to convert this into one big logarithm. So the first thing I'm going to do is I'm going to put my powers on top. So I have now log of x to the 6th minus log of y to the 1/3 minus log of z to the 2/3. And now when I group all these together, because there's addition, adding and subtracting, we can just put it as like multiplication, division. All the positive logs are going to, their inside is going to be on the top, and all the negatives, because those are the ones that are the bottoms of the fractions, are going to go to the bottom. And there we go. Now that's just a single logarithm. Going to this next one, it says solve the exponential equations, give an exact answer in terms of common or natural logs and approximation. So we'll have to solve it in terms of log, and then we'll plug that into our calculator. So first thing I'm going to do on this first one is I'll subtract 22 from both sides. So 8 to the 4x minus 1 is going to equal 141. Now I want to get my x out of the exponent, so I'll take a natural log of both sides. I can bring my power down, so 4x minus 1 ln of 8 equals ln of 141. I'll go ahead and distribute this. So I have 4 ln of 8x minus ln of 8 equals 1 ln of 141. I'll add the natural log over, so 4 ln of 8 x equals ln of 141 plus ln of 8. Then I'll divide by 4 natural log of 8, so x equals natural log of 141 plus natural log of 8, all divided by 4 times the natural log of 8. So that's my exact answer, and my approximation is going to be 0.8450 to 4 decimal places. And I'll rewrite this up there. That's my final answer. Okay, moving on to the next one. And by the way, side note, I use natural log just because that's the one I default to. But if you want to use log base 10 or like some other log, that's totally fine. We usually do, it wants common log or natural log, so we want to do log base 10 or natural log. I just chose natural log, but log base 10 is totally fine. Going on to this one, I'll say 100 equals 700 e to the minus 0.2x. I'll divide each side by 700 to get the e term by itself. So I have 1 over 7. 100 divided by 700 can just become 1 over 7. E to the negative 0.2x. Let's take natural log of both sides. Natural log and e cancel, so we just get left with our exponent. And I can divide by that, so ln of 1/7 divided by negative 0.2 equals x, which is going to be approximately ln of 1 over 7 divided by negative 0.2. I got 9.7296. Yeah, there we go. 9.7296. I'll go ahead and write this up there. For part C, I'm working this one over here. So we have 9 to the x plus 5 equals 7 to the 2x minus 3. Well, I'll take log of both sides. And that will drop down our exponent, so x plus 5 ln of 9 equals 2x minus 3 ln of 7. I'll distribute both these natural logs. So I have ln of 9 x plus 5 ln of 9 equals 2 ln of 7x minus 3 ln of 7. I'll shift a little bit over for the next one so I don't run into the words. I'm going to group all my x's on one side, so I'll subtract this over, and all my non-x's on the other, so I'll have ln of 9x minus 2 ln of 7x equals minus 5 ln of 9 minus 3 ln of 7. And if you want to put the x's on the other side and the other stuff on the, you can switch the sides. You'll get the same answer either way. And then from here, I have all the x's on the one side, so I'll pull the x out. And then I'll divide by the ln of 9 minus 2 ln of 7. So that's my exact answer right here, which is approximately, when I plug this in, 9.9279. And I'm going to erase all this. I'll put it up there so you can actually see this. And we'll go ahead and we'll go on to the last one. Okay, finally for this last one, I'll work it over here, and then I'll rewrite my answer over there. 16 to the 3x minus 1 equals 64 to the x plus 2. Well, I'll do just log base 10 this time, just to change it up. It's going to be the same thing either way, though. Now, I can bring my powers down. 3x minus 1 log 16 equals x plus 2 log of 64. We can distribute these. So 3 log 16x minus log 16 equals log 64 x plus 2 log 64. I'll put all my x's on one side, all this without x's on the other, so 3 log of 16x minus the log of 64x equals 2 log of 64 plus the log of 16. Now from here, I'm going to pull out all my x's. And it's just going to equal that. I'm running out of space. And then I'll divide over. So I'll get x equals 2 log of 64 plus log of 16 over 3 log of 16 minus log of 64. And plugging that into my calculator. I know there's another way, easier way to do this, but this is like the way to do it, like with just logs. I'm going to get about x is equivalent to 2.6667. And that's the answer for that one. I'll go ahead and write that up there. I know one like there's another way we could have done this, like where you do like log base 2, because 16 and 64 can reduce down a little bit differently with log base 2, but you're going to get the same exact answer at the end either way. So just letting you know, like, there's different ways that you can see these answers for these. Okay, going on to this next one, it gives us these equations. We need to solve logarithm equations. Well, on this first one, this is actually pretty nice, because if you have a log, the same base on each side, well, I can do 10 to the log of x squared plus 7x equals 10 to the log of 18. And the 10 and the log cancel, and we get x squared plus 7x equals 18. We can subtract that over. X squared plus 7x minus 18 equals 0. That factors to x plus 9, x minus 2. X equals 2 and minus 9. But we need to double check to make sure both of those work. So if I plug in 2 and I plug in minus 9 into that, I just need to make sure I don't get like a negative answer, like, you know, a log of a negative. And in this case, I've already gone through and checked. We're not going to have to deal with that, but I encourage you guys to check on your own. Going to this next one. Well, unfortunately, we have this 2 here, so we can't just jump to the same trick. But what I'm going to do is I'm going to add the 4 over, so we'll have, or add the log on the right side over, so log 4 of x plus log 4 of x minus 6 equals 2. And when you add two logs with the same base, we can just multiply them on the inside. So log 4 of x times x minus 6 equals 2. And now I'm going to say 4 to the log of 4. And I can distribute that. So x squared minus 6x equals 4 to the 2. Well, 4 to the 2 is 16. And over here, those cancel. So we get x squared minus 6x equals 16. So x squared minus 6x minus 16 equals 0. Gives x minus 8, x plus 2, x equals 8, and negative 2. Well, the 8 is going to work, but when I plug the negative 2 in, log base 4, I'll have to plug it into log base 4, and you can't have a negative inside a log, so 2 is not going to work. So I'll scratch that out. Doesn't work. Work, not walk. So that answer is going to be x equals 8. And it's just one answer for that one. Moving on to the one after that. On January 1st of 2000, the population of Texas was approximately 21 million people. On January 1st of 2010, it was 25.2 million people. So the first question is, write a function in the form p of t equals p naught, each to kt that represents the population in millions of Texas, t years after January 1st, 2000, round k to 5 decimal places. Well, first thing we already have is we know what p naught is. P naught is your initial population. And if we're looking at starting at January 1st, 2000, and we're given that, well, that means that is 21. Okay, so we have, it's going to look something like p of t equals 21 e to the kt, but we figure out what k is. We know another point in time. We know 10 years later, so when t is 10, population, which is p of t, is 25.2. And now I can divide each side by 21. I can take a natural log of each side. I can divide by 10. Oh, whoops. And when I plug that into my calculator, I get k equals about 25.2 divided by 21. 0.01823, because that's 5 decimal places. Okay, so what does that mean for our answer for part A? Well, that means I'll put it over here, that P of t will be 21 e to the 0.01823 t. And that is our model for it. Now I'll erase this and we'll look at the next one. Use the function to predict the population on January 1st of 2022. Well, 2022 is 22 years after 2000. So that means we just got to plug 21 into our equation. 23 times 22. I'm going to go and do that. 0.01823 times 22. And I got 31.36, which is to the nearest one decimal place is going to be 31.4 million. Okay. And now this is predict which year the population will reach 40 million. So we're going to say 40 equals our model, and we'll solve for t. So 40 over 21 equals e to the 0.01823 t. Natural log of 40 over 21 equals 0.01823 t. So ln of 40 over 21 over 0.01823 equals t. Putting that into my calculator, I get around sorry, I plugged it in wrong. Divided by 0.01823. I got about 35 years, so that's approximately 35. So the answer is going to be, the answer for that one, 2035, because that's 35 years after. You know, we got to make sure, like, it's not going to happen in the year 35. That happened quite a while ago. It's going to be 2035, because that's 35 years after the year 2000. Go to the next one. Use a function to determine the age of an artifact that has 38% of its carbon remaining. Okay. Well, this one's kind of tricky, right? Because we don't know what the initial amount is, but we actually don't need to, because we know that the amount that we care about is 38% of what we started with, or 0.38, the initial amount. And what are we going to do with that? Well, we want to figure out when does that happen. So we're going to plug that in to our amount, and we're going to solve for our t to figure that out. So we can divide both sides by q naught. So 0.38 equals e to the minus 0.000121 t. So it turns out q0 didn't matter. I'll take a natural log of both sides. And I'll divide by negative 0.00121. So ln of 0.38 divided by negative 0.000121. I got that t will be approximately 7,997. So we'd say 7,997 years old. So that's like older than the pyramids. Pretty impressive. Okay, going on to the next one. Well, I think the questions got put onto the next page, so I'm just gonna, I guess, like, rewrite the question in the next one. Okay, so I went ahead and tried to write down all the stuff that from the last one to top. So determine the number of computers initially affected when the virus first started. Well, NFTs are the number infected. So when it first started, or first detected, so that means your t is going to be 0, because t is the number of months since detection. So n of 0 is going to be 2.4 over 1 plus 15 e to the negative 0.72 times 0, which it will be e to the 0 is just 1. Anything to the 0 is 1. And 15 times 1 is just 15, so 2.4 over 1 plus 15. So 2.4 over 16, which is 2.4 over 16, I believe 0.15. So 0.15 in millions, so if you multiply that times 1 million, so that's 1 with, I believe, 6 zeros after it. 1, 2, 3, 4, 5, 6, yeah. You get 150,000. So 150,000. And it's important to remember that this is millions, 0.15 millions of computers. So computers. To find how many computers were affected after 6 months, well, plus 6 in for t. So 2.4 over 1 plus 15 e to the negative 0.72 times 6. Well, I'm just going to go ahead and plug that straight into my calculator, and I'm getting 2. So that is 2 million computers. What is the limiting value of computers affected according to this model? Well, your limiting value is always the thing on the top. So 2.4 million computers. Now for 77, this is our last one. We've made it. The number of sunlight, y, in Langley's is measured for 6 different depths, x, in Lake Lyndon B. Johnson, Texas, as noted in the table. So we use our calculator to find the exponential regression equation that fits the data. So I'm going to go ahead and put this into my calculator. We're going to go to our stat, edit, and we can change our list. So after I get my data in the table, I go to stat again, I go to calc, which is just to the right arrow, and go down to, you can't see on the first part, you gotta go down a little bit, it's going to be xreg, it's I believe number 0 on the list. And what I got was that y is going to be, to 100th is 2 decimal places, so 399.71 times, and then my base is 0.74, just 0.74. to the x. Now we need to figure out where x is my depth, so now it gives me, for part B, a depth of 15, so I'll do y equals 399.71 times 0.74 to the 15th. So put that in my calculator, times 399.71. I got 4, to the nearest length, it's just going to be, I got 4.37, but to the nearest it's going to be 4, so 4 Langleys, whatever those are. That's my answer for that. And finally, determine the depth at which the amount of sunlight would be 2. So I'm going to say 2 is going to be my y. So it's going to be 399.71 times 0.74 to the x. I'll divide over the 399, so 2 over 399.71 equals 0.74 to the x. To get the x out of the power, I'm going to take a natural log of both sides. And bring the x down. I'll keep working up here, so ln of this whole thing and so I can just divide by ln of 0.74. That gives me x. So, and we're going to round to the nearest meter, so just round to the nearest whole number. Over. That gives us, I got 17.6 when I plugged it in, so that rounding up would be 18 meters. And that's it. So that's the final part of our exam review videos. I hope you found these helpful. Hope you enjoyed my voice because I did quite a few of these. Good luck with your finals. I really hope you all do well. I hope that all these made sense. Make sure to stop by the MLSC if you're confused with anything. We have a lot of great tutors that will be able to help answer your questions. Thanks.